I would like to extend a warm welcome to Mr. Vikram Gandotra, who is currently the head of utility sales and strategy at Siemens Limited. He is an accomplished professional with a sound domain knowledge of the power transmission and distribution sector, particularly in the power utilities digitalization application. Mr. Gandotra is the chairperson of the Public Policy Committee and is a member of the National Executive Council and the past chair of the Smart Grid Division of EMA. He is a BE and an MBA graduate and a research scholar at IIT Delhi. It gives me immense pleasure to invite Mr. Vikram Gandotra to present his talk on making grids smarter with energy intelligence.
Energy transition is a reality. Earlier, we used to think that it is something for the developed countries and India is not going to be affected by it. However, we all know over the last decade how this has changed our world in India too. We are also now amongst the leaders in energy transition. And of course, there are a lot of uncertainties. We are now living in a world full of volatile production. We are also now getting a lot of new technologies which are playing a major role. Yeah? We are also seeing new consumptions like electric vehicles and heat pumps. We are seeing digitalization in terms of IT/OT convergence, new grid technology protection, legal requirements, and many new business models. Yeah, vehicle to grid, grid to vehicle. What all is happening? And pilot projects are there around the world, and we are also participating in many. So business priorities, they are now getting changed. If you look at the market drivers on transmission, we have, of course, large scale renewable in India. We have a drop of system inertia and reactive power imbalance, limited grid capacity and expensive redispatch. And when we look at the distribution, there are billions of distributed energy resources which are entering our distribution grid. Either they are going to be supplying the power or they are going to take the electrical power. So these are a very dynamic and complex flow of power which is happening. And unfortunately, the distribution as compared to transmission is plagued with a lot of limited visibility of what is happening in the grid. The low voltage side is very dark. The utility does not know what is happening. Whereas if you look at now the rooftop solar, which is going to be the next big wave of solar energy, which is going to come into our grid, it will happen in the distribution side, which is unfortunately not as visible to the system operator as the transmission side is. Then if we see what is happening with the digitalization, so what we call the IT and OT convergence, there was always a IT side and the OT was an isolated island, which was more with the OEMs like Siemens, ABB, and the others would always have their own systems. So what is happening is that both these systems, they are no longer in different islands, they are coming closer and overlaps are happening. A lot of data from the field is required in the IT, goes for the management reporting, and vice versa, which were probably things like the GIS network, which was handled by the IT departments of the company. They are coming into the OT and it tells the engineers how to manage the grid. New developments have happened like the IoTs and the artificial intelligence, machine learning, data analytics, and increased transparency, which is made available through new IT tools. exchange of data is happening much, much more than before. There is exchange between, for example, the CRM, the customer management system, and the job spatial information system, between the billing system, and also at the other side there will be a fault system, SCADA system, outage system, which will be connected to the field force management system. So this is a new dimension which is happening, making things more complex. Cloud computing is coming in. It has its advantages because the utility is to, not to focus on competencies which are not their core. That is, for example, IT and communications. You can depend on somebody who's managing your system on cloud. However, there are still issues which make it across the world not as prevalent for real-time SCADA and EMS, DMS applications at this point in time. Cyber threats, they are a reality. We live in a world where electrical systems, they are considered critical infrastructure for any country, and they are threats, non-stop threats, not just physical threats, but cyber threats which are happening by enemical forces around the globe. Yeah. So these are the some of the priorities under which we as managers have to see compliance, resilience, and efficiency. So the grid has to be planned under such uncertain conditions, making use of the digitalized tools as well as ensure that there is adequate amount of cybersecurity. Now, conventional investments will not provide the speed to, as you see on the y-axis, over the years, the DER hosting capacity which is needed by the grid for various applications, that is going to go up, yeah. And what we see is that this gray area, this is the growth which will be there in the conventional investments. However, what we are looking for is a much higher growth in the hosting capacity. And this growth in hosting capacity can come by making the grid more and more flexible, adaptable, and this will be a limitation as we move forward. And what happens is that more and more of this investment in future will come towards software and IT/OT systems, which will help to host these thousands and millions of devices which are going to be connected to the grid. Now, you may ask that don't we need the normal conventional investments? Yes, we do. We very much do. We need all the copper and aluminium and oil and for transformer. I mean, of course, everything is there. Yeah, circuit breakers. But as you become more and more complex in the grid, you cannot do without more visibility. You cannot do without more control. You need too much of flexibility, as there is going to be a lot of variation of demand, supply, and a lot of new business models are going to work around people who are going to generate local electricity, people who are going to be on the move as a consumer, and there will be newer applications which are going to come for electricity. Electricity will for sure be a much larger source of energy in the coming years as it has been in the past. So for cooking, we will be using more and more electricity. For transport anyway, we are seeing this is already happening, but it will become more. Yeah, India is in the forefront already. If you compare with some other advanced countries like US, for example, we are ahead in terms of electrification of our mobility, not only the road mobility, but the trains. Yeah, our train networks is more connected electricity than any others. So now we are seeing that the roads are also, the transport will also become more and more electrical. Then what that means is that the demand is also going to keep changing very fast, geographically as well as chronologically in the time, as far as what was the peak earlier in the two peaks system. We don't know in future in whether it will be one peak or three peak, or it could change, because the way electricity is going to be consumed and the way electricity is going to be generated is totally different. Yeah. And this cannot be done or managed without a lot of tools, which will be software and intelligent tools. Yeah. So just to show, reiterate that as per a Bloomberg and McKinsey report, distributed energy resource will increase by a factor of 7 by 2030. Electric vehicles, we already know, and as I said, electrification across sectors will lead to doubling of electricity demand until 2050. So what we see is that we need more and more automated and adaptive ways to stabilize the grid. So stable grid, despite the voltage generation mix by smart energy management technologies, then we need more transparency for prosumers, adaptive grid and intelligent load balancing using microgrid and virtual power plants. So virtual power plants is the form of making very small distributed generation power into a dispatchable power, something which can be planned and sold and traded in a systematic manner. So these are the sort of tools which are going to come up, the virtual power plants, then improve asset monitoring on all voltage levels, reduction of asset downtimes. As the system and life becomes more and more electrical, it is very critical to continuously monitor the health of the assets and across the grid, and we need to reduce the downtime. We know to know in advance that there is a problem which will happen in my transformer maybe after a month. So I should be ready for it. Whatever I need to do, I need to take care in advance. Yeah. So these are the type of solutions that for asset monitoring which will come in play, then faster fault location and clearance. So one very distribution, this is more to do with distribution. The problem is always to locate and clear the fault so that it is outage is reduced to the minimum level. So again, there's a lot of intelligence which is coming into the grid, which will help to reduce the outages. And as I mentioned earlier, the cybersecurity is a real world topic now. People who know what was the attack in Ukraine some years ago, not a physical attack, but a cyber attack which brought the whole grid down. You know. So what are the tools that are needed? One, of course, is the planning and consulting for integrating renewables. Our friend that just in the first talk told us about planning. So this is something where it is very important. And this PSSE is the tool which is used here. We need consultants. We have got consultants who give the real world advice, what is needed. Then the digital twin. So this is again another new concept which is coming up in the power system. We are able to create the whole model of a network. It could be a model of a substation. It could be model of a larger, feeder or next higher level, maybe at a grid level, city grid or state grid or maybe national grid. Yeah. So all these different models can be created, and these models are not just pure electrical models. We can also overlap spatial information from the photographic data which is collected using drones, and we create real, replica of the real system, which helps the engineers manage the system in terms of better performance in all aspects. Then when we look at meter data management, this is again at the distribution side. Here are these tools which are connected to millions of meters, and how to make sense out of those million of data points. Yeah, these are something which these tools like energy IP meter data management helps us to do. And microgrid controller is to manage a microgrid. These are tools which are already there. I also talked about the PSS, but for spectrum power, that is a grid control, SCADA software. And on the other side, even within the distribution automation, there are a lot of new tools and, localizer, navigator sort of solutions which are coming up. If you look at the e-mobility, now e-mobility is also interesting because we need not only chargers, but we need systems to manage the charging network. Yeah. So these are the sort of solutions that we are making available. We are also roped in partners who are doing the consulting for us for areas that are they are best in, for example, software and the other, planning, strategic planning. So just to sum up, so there are challenges of limited visibility of the DR. I said here we give solutions to increase the transparency, EV charging to, forecast what has been the load and across large number of sites. We are able to do that through solutions for this. In the load management, there is real-time energy at enterprise globe level. This needs to be monitored. And then what is another thing I told you that there are a lot of systems which are connected now with each other. And this easy connectivity can be provided only via APIs, protocols, which are, across vendors, they are similar. So this is sort of engineering that we are providing. Yeah. And if I look at some examples we have done for this DSO in Norway, we are able to give a fully integrated grid operating center at all voltage levels. Yeah. Yeah. So looking at the substation side, distribution grid, here we are providing solutions for increased transparency at the lower grid levels. And we are able to monitor both MV as well as LV assets to avoid downtime. And one very interesting thing is the continuous monitoring of the protection devices. You know what are the settings? Mr. Venkatesan said that yes, so now the settings is something which needs to be looked into for protection devices when the changes in the network. So this is again possible when we are able to log into these devices, see those settings, update those settings. So all that is now possible with new tools that we have got. And of course, we have got real-time fault notification and fault location, like also. Power quality monitoring is again something which we are doing to identify unbalanced load, energy efficiencies. So in a nutshell, I mean, these are some of the issues which are there and which are being addressed for, giving value to the utilities, whether it is OPEX saving or CAPEX deferment, managing the risk, and managing cybersecurity. So yeah, so that is all from my side currently. If there are any other topics or any discussion, I'll be happy to contribute to them. Thank you.
Thank you so much, Mr. Vikram, for sharing your thoughts on making grids smarter with energy intelligence.
For viewers who have joined us today, we would like your feedback and encourage you to stay connected with us via our social media handles. EPR Magazine is now available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. We also request our viewers to stay tuned for future interactions.